Hello, my name is Jeslyn and I'm here today to talk to you about climate change. But before I even start, what even is climate change? Well, climate change is the most common name used for changes in usual weather events around the planet that are associated with an increase in the average temperatures of the Earth. Let's start with the main components of the Earth's climate system. The main components include the sun, the oceans, the atmosphere, topography, and landmass configuration. First, I will talk about the sun. The sun is one of over many billions of stars in our galaxy, which we call the Milky Way. With a diameter of 1,390,000 kilometers and a mass of 1.989 up to the 30th power kilograms, the sun's mass occupies over 99.8% of the total mass of our solar system. Our sun's power is measured at roughly 386 billion megawatts, which is generated by nuclear fusions within the sun's core. Its energy moves from the core to the surface through a process of constant absorption and then radiation at lower temperatures. Once the energy has reached the surface, it is mainly visible light. So, how does the sun affect the Earth? Well, as we all know, the sun warms the Earth through solar radiation. Some believe that the sun is related to the cause of recent climate change, but scientists believe that the sun is actually not the cause for global warming, and rather that it is something that we humans have played a large role in. However, the sun has been the cause of major temperature changes in the past, including a decrease in solar activity, which scientists speculate was a main cause of the ice ages. Another way the sun affects the Earth is through the seasons. A lot of people believe that the seasons occur due to the Earth's proximity to the sun, but this is actually incorrect, as the seasons are caused by the tilt of the Earth's axis and how it revolves along its orbital plane. A very long time ago, the Earth was knocked off its axis by a collision with another celestial object. As a result, when the Earth orbits the sun, different areas of the Earth get different amounts of sunlight, since the axis always points in the same direction. This is the same reason why the seasons are different depending on if you're located in the northern or southern hemisphere. Now let's talk about the oceans. The oceans make up an ongoing mass of salt water that surrounds 70% of the surface of the Earth. People generally divide them into four separate oceans: the Pacific, Atlantic, Indian, and Arctic Oceans. All of the oceans together, also called the World Ocean, holds approximately 97% of Earth's total water supply, which is around 1.35 billion cubic kilometers of water. The oceans absorb the majority of the sun's radiation, especially at the equator, and they help to evenly distribute that heat throughout the globe. Heat from the oceans is spread through evaporated water molecules that move in the surrounding air. The evaporated water increases humidity in the air and forms different types of precipitation. The tropics experience much more rainfall because heat absorption and evaporation are highest in those areas. Within the oceans are a complex system of currents, which are movements of water in a continuous flow. Currents bring warmer and cooler water throughout the globe. For example, the warmer temperatures of Western Europe are largely caused by water currents carrying warm water from the south. Next is the Earth's atmosphere. Our atmosphere protects us from enough of the sun's radiation so that in our solar system, Earth is the only planet that has the right conditions to sustain life. As the sun radiates heat to the Earth, much of this heat is trapped by greenhouse gases located within the atmosphere and then is redistributed more evenly throughout the Earth. This is known as the greenhouse effect. Included within the greenhouse gases are carbon dioxide, methane, water vapor, nitrous oxide, and chlorofluorocarbons. Many planets like Mars don't have enough of the greenhouse effect to sustain life, and thus much of the planet is frozen. On the other hand, planets like Venus have way too much greenhouse effect, so the whole planet is way too hot to sustain any sort of life. The Earth's atmosphere is about 480 kilometers thick, and as the altitude increases, the amount of oxygen decreases, as does air pressure. To put some numbers on it, at sea level, air pressure is around 14.7 pounds per square inch and is 10 pounds per square inch at 3 kilometers above sea level. After atmosphere is topography. The definition of topography is the description of the physical aspects of an area. This includes mountains, crevices, and other areas of higher and lower elevation. Changes in elevation, specifically around higher areas like mountains, determine the distribution of precipitation throughout the Earth. When compared to water, the Earth's land generally becomes warmer more easily, creating differences in surface temperatures called hot spots and cold spots, where surrounding air pressures vary. In addition, these hot and cold spots also create hot and cold fronts that travel around the planet via the prevailing winds, and the ocean's currents carry these airs with different temperatures to coastal regions. So, areas closer to coasts or large bodies of water usually vary less in temperature and generally have more precipitation because there's more water vapor in the air above these large bodies of water. As these masses of air with water vapor heat up, they rise and move over continental areas and then form precipitation as they cool down. When an air mass hits an area of higher elevation, such as a mountain, it is forced to rise. Once it rises, the vapor condenses as it cools. The side of a mountain that receives air masses and has more precipitation is called the windward side. For example, Seattle gets a lot of precipitation because it's on the windward side of the Cascade Mountains. The opposite side of the windward side of a mountain is known as the leeward side and has less precipitation because air masses with water vapor have released the water vapor through precipitation on the windward side. An example of this is the many areas east of the Rocky Mountains that have less precipitation because they are on the leeward side. Also note that mountains are cooler than areas of lower elevation since the air of higher places are less dense and holds less heat. Finally, we have landmass configuration, which, similar to topography, also talks about the land. Firstly, latitude of the land affects temperatures, which just means how far north or south you are from the equator. Latitude establishes the amount of solar radiation received in a certain area. Generally, as you move further away from the equator, temperatures become cooler. The reason for the areas closer to the equator being warmer is because they receive the most solar radiation. In addition, the land's reflectivity also affects climate, since the amount of heat absorbed or reflected determines how much heating occurs in the surrounding areas. For example, places with snow and ice are good reflectors and are cooler as a result because heat is reflected and the air can't retain much heat because of a lack of moisture. Contrarily, places with lots of vegetation absorb the sun's radiation during the day and radiate the heat back to the surrounding air at night, and cause temperatures to be higher. Also, places with less vegetation, such as deserts, heat up slower during the day and lose heat faster at night because there's less moisture in the air to trap heat. Land use can also affect climate, as densely built cities can lead to warmer surrounding air temperatures, different amounts of precipitation, and change in daily range of temperature. This occurs because of the heat absorbed and reflected off of the different materials used to create buildings. Now I'm going to talk about the transfer of heat between and within the hydrosphere and atmosphere and how it affects air and water currents. Heat transfer in the hydrosphere and atmosphere mainly occur due to convection and radiation. The oceans hold a lot of the sun's heat by storing and absorbing it, and when airs of different temperatures come into contact with the ocean surface, heat transfer in the form of conduction occurs. A lot of the world's precipitation originates from the oceans, and when water vapor condenses and precipitation falls, heat is released into the atmosphere. Winds and ocean currents move warmer temperatures to the poles and cooler temperatures to the equator, making the global temperature more evenly distributed. Ocean currents can be created by winds and changes in density of water masses. Changes in water density are mainly caused by temperature changes along with salinity, gravity, and earthquakes. Temperature affects water density because, as we know, water gets less dense when it freezes and also when it evaporates, but on average, water is most dense at 4 degrees Celsius. Air currents are also affected by temperature, since differences in temperatures create different pressure zones, with lower pressure being near the equator. Cooler air around the equator moves back to the low pressure zone after cooling down, and the rest of this warmed air travels to the poles. Alright, on to the next topic, sinks and sources of greenhouse gases. So firstly, what is a sink and what is a source? Well, a sink is a reservoir that can absorb or store these greenhouse gases from its natural cycle, and a source is a process or activity that results in the release of greenhouse gases. I will be covering the sinks and sources of major greenhouse gases such as carbon dioxide, methane, nitrous oxide, and halocarbons. First, I'll explain about carbon dioxide. One of carbon dioxide's largest natural sources is animal and plant decay, along with forest fires and volcanoes. A major anthropogenic or human-made source of carbon dioxide is the process of burning fossil fuels, which also releases other types of greenhouse gases as well. The natural sinks for carbon dioxide includes trees and other vegetation, as the process of photosynthesis converts carbon dioxide to glucose and oxygen. Another natural sink are the oceans. However, the carbon cycle with the ocean occurs on a large scale that happens very quickly. This means there's not a lot of long-term storage of carbon dioxide happening in the ocean. However, some scientists believe that a lot of the extra carbon dioxide caused by humans is actually being absorbed by the oceans, though they are still researching this phenomenon. Artificial sinks for carbon dioxide include reforestation and afforestation to try to increase the amount of plants that can convert carbon dioxide into oxygen. Other sinks include landfills and man-made carbon capture and storage processes. Humans have made artificial sinks by creating or using existing underground formations to store carbon, as well as assisting in the growth of microorganisms in the oceans by fertilizing the surface with iron. After carbon dioxide, we have methane. Major natural sources of methane include permafrost, gas hydrates, termites, wetlands, freshwater bodies, oceans, non-wetland soils, and more. Its major human sources include the production of fossil fuels, livestock and manure management, rice farming, and biomass burning. Did you know that 60% of global methane is produced by humans? A major natural sink of methane is the absorption of soils through methane oxidizing bacteria called methanotrophs. Humans can also capture and use methane through technologies in industry like coal mining or waste management, such as landfills. Next, we have nitrous oxide. Nitrous oxide is emitted from soil and oceans in nature and is released into the atmosphere due to human activities such as the cultivation of soil, creating and using fertilizers, and burning fossil fuels. Nitrous oxide is a very powerful greenhouse gas because it is so hard to be suppressed. The main way nitrous oxide is removed from the atmosphere is through reactions of light and excited oxygen particles. On a smaller scale, nitrous oxide can also be removed through denitrification of soil bacteria that convert nitrous oxide into nitrogen gas. Recently, humans have created denitrifying bioreactors which can imitate the natural process of denitrification. For our final greenhouse gas, we have halocarbons. Halocarbons are generally made of synthetic chemicals produced by humans, but can also be produced during the process of decomposition of organic matter. Specific human sources include semiconductor manufacturing and producing metals like magnesium and aluminum. Natural sources include burning wood and volcanic activities. Exact human and natural sinks are difficult to determine since this greenhouse gas is not very concentrated in the atmosphere. Now I'll be talking about the global effects of climate change and what initiatives have been put forth. We'll specifically be covering 3 countries: Canada, the United States of America, and China. First is Canada. A major problem that Canada has is forest fires. The forest fires are caused by wetter winters due to global warming, and this means that there will be more vegetation. In addition, prolonged summers means that there will be a higher chance for forest fires to occur. In 2017, British Columbia achieved a new record of 900,000 hectares burned up, and in 2016, a devastating fire swept through Fort McMurray, destroying 2,500 buildings and caused 90,000 people to evacuate. To help with the forest fire problem, Canada has put forth many services and projects such as CANFIRE and the Canadian Forest Service, or CFS for short. CANFIRE studies the effects of forest fires so scientists can more accurately predict future forest fires. The CFS works to develop ways to protect people from fires and supports wildfire management. Canada has also introduced many climate change initiatives in general to monitor carbon pollution, create more clean technology and jobs, reduce emissions with clean energy, and making the nation more suitable to deal with climate-related disasters. With these initiatives, Canada hopes to reduce the effects of climate change, including forest fires, and figure out an effective way to combat global warming. The best way to prevent forest fires is to put them out before they can spread any further. With these initiatives, researchers can better monitor and predict where forest fires will occur and safely put them out. After Canada is our neighbor, the United States. The United States has to deal with a lot of problems caused by climate change, such as extreme weather events, droughts, and air pollution. I'll be focusing on air pollution in the USA and what they've been doing to try to lessen the damage. Even though America is one of the richest countries in the world and spends a lot of money on healthcare, they're just ranked 23rd for air quality. Studies show that approximately 130 million Americans live in cities with unhealthy levels of air pollution. The health risks of living in a city with poor air quality include asthma attacks, lung cancer, and developmental issues in children. So, what has the United States done? The federal government hasn't been doing much as of late. However, they have introduced the Clean Air Act with the goal to control and monitor the entire nation's air pollution levels. The Clean Air Act has provided the foundations for many existing climate change policies, as well by bringing other problems into focus. This initiative also protects public health and welfare by regulating emissions of harmful air pollutants. For our final country, let's fly to the other side of the planet to China. Similar to America, China also has a large problem with air pollution, especially with large cities like Shanghai and Beijing. Millions of people in China are breathing in harmful pollutants every day, which is why in China you will often see people wearing face masks. The reason for China's air pollution is because the nation is largely driven by fossil fuels and thus emits the most carbon dioxide in the world, along with other greenhouse gases. In recent years, the government has been very active in trying to reduce the effects of climate change on air quality. However, there is still much work to do. China has just recently launched the 3-year action plan for winning the Blue Sky War. This initiative is an attempt to produce and use more efficient technology to replace large coal-run factories. The goal of the 3-year action plan is to lower the level of air pollution of many cities, as it is estimated that over 300 cities in China have dangerously poor air quality. This plan is really just a continuation of the successful, now expired 5-year plan, where over 70 cities drastically reduced their air pollution levels. This initiative wants to bring down the air pollution levels of 200 cities to the national standard to improve upon the citizens' health with a specific focus on the development and use of clean energy to reduce harmful air pollutants. Now let's talk about natural and human factors that contribute to climate change. 2 natural factors that contribute to climate change are volcanic eruptions and variations in solar radiation. Firstly, volcanic eruptions release carbon dioxide into the atmosphere, as well as volcanic ash and sulfur dioxide. These aerosols can cause cooling of 1 to 2 years by blocking a variable percentage of sunlight. Sulfur dioxide particles combine with water particles in the air to form sulfuric acid, which is transported by winds around the planet in generally east or west directions. Secondly is variation in solar radiation, which only ever varies by a small amount. This variation is tied to the amount of sunspots, which are the darker areas that appear on the sun's surface that occur when a strong magnetic field disrupts the movement of gases that bring up heat energy from the sun's core. When there are more sunspots, the sun radiates a bit more heat since these spots suppress heat. This heat then goes to surrounding areas, causing those areas to be hotter than usual. Less sunspots on the sun generally means cooler temperatures. 2 major human factors that contribute to climate change include deforestation and burning fossil fuels. So firstly, deforestation is the process of cutting down trees and bushland. This affects climate change as plants are a natural sink for carbon dioxide because of photosynthesis. We humans clear vegetation generally because of farming, sell timber, urbanization, and infrastructure development. When the plants are removed or burned down, carbon dioxide returns to the atmosphere and a natural sink for carbon shrinks. Deforestation is an unnatural process of the removal of trees, so we experience unnatural climates and temperatures as a result, since the planet needs a good balance of sinks and sources. Next, we have burning fossil fuels. Fossil fuels are buried flammable remains of organic matter that are converted to coal, crude oil, natural gas, or heavy oils due to being open to extreme heating and pressure in the Earth's crust over many millions of years. We burn fossil fuels like coal and gas to create electricity or power our vehicles and release carbon dioxide into the atmosphere in the process. This contributes a lot to greenhouse gases. Burning fossil fuels is the largest source of carbon dioxide on Earth. So I've been talking a lot about greenhouse gases a lot through this video, but what specifically are greenhouse gases? Well, these are gases and substances that thicken the atmosphere and trap heat from the sun within the planet, making the Earth much, much warmer. When humans burn fossil fuels and clear forests, we are adding more greenhouse gases into the atmosphere, which makes it harder for heat to be reflected back into outer space, and instead it just stays trapped between the atmosphere and the Earth's surface, which is why the planet is getting hotter. A surplus of greenhouse gases is mainly due to the use of fossil fuels to generate energy. Burning fossil fuels contributes to releasing an unnatural amount of carbon dioxide into the atmosphere, and as I mentioned before, the largest source of carbon dioxide in the world, including natural and anthropogenic sources, is the burning of fossil fuels. Deforestation also contributes to the greenhouse effect, as trees and vegetation are a natural sink of carbon dioxide, and once that sink is gone, carbon dioxide is no longer removed, and we are left with too much of it for a clean environment. Volcanic activity also contributes to the greenhouse effect by releasing carbon dioxide when they erupt, and through underground lava, but their contributions pale in comparison to the amount of carbon dioxide released by human causes. To be more specific, on average, volcanoes release less than 1 billion metric tons of carbon dioxide per year, but burning fossil fuels releases more than 3 billion metric tons of carbon dioxide emissions per year. So even though a lot of proof has been brought forth that climate change is definitely occurring, some people still don't believe that climate change is real. Those who do believe in climate change represent the majority of society. On Climate Change Atlas, a survey based off of researchers from geology, astrophysics, oceanography, atmospheric physics, and many other disciplines show that 97.1% of scientists believe in climate change, while the other 2.9% either reject it or are still uncertain. Many people believe in climate change because of hard evidence and recorded data, such as when CO2 and other greenhouse gas levels rise, temperatures rise as well. People also take into consideration other evidence, such as the following gathered from NASA, Global Climate Change, that carbon dioxide levels have never been this high in 650,000 years. Average global temperatures are up 1 degree since 1880. Arctic ice is decreasing and sea levels rise 3.2 millimeters per year. We are able to find accurate data from Earth-orbiting satellites and other technological advances gathered over many years. The majority of scientists are more than 95% confident that humans are the main cause for climate change, and in general, people believe that something should be done to prevent climate change before it gets out of control, like creating laws, cleaner technology, and adapting to new issues. People who value changing human behavior also value clean environments for the benefit of humans and animals. However, there are still some people who acknowledge climate change and refuse to do anything about it, since they don't think anything they do now will have any effect on them, and if climate change does worsen, it won't affect people of this lifetime. For the people who choose not to believe in climate change, they might not be completely convinced of climate change, or they completely reject the idea. Many people think climate change isn't happening because there is no evidence, which is not an entirely true claim, since there is clear proof of climate change. It's just that people who don't want to believe in climate change don't bother to look at the evidence provided for them. According to the Climate Change Reality Project, it states that many people don't believe in climate change because of an effect called confirmation bias, which basically means that when results show information that contradicts with what people believe, they often regard it as fake or incorrect and choose not to believe it. Some say that any proof or evidence is fake science and is only meant to try to sway people's opinions. An example of this is the United States' President Donald Trump, who doesn't believe climate change is real, and since the election in 2016, more people have openly stated that they believe climate change is fake, most likely under his influence. A very small percentage of people don't trust science. Also, many people who believe climate change isn't happening don't believe in recent scientific breakthroughs either. People also don't think climate change is real due to their own experiences. For example, those who live further north might not believe that climate change is real because they still receive ice and snow. People who don't believe in climate change generally don't value scientific explanations with proof and don't care about or ignore efforts to reduce climate change. In my opinion, I believe that climate change is actually happening, as researchers have provided us with clear evidence that climate change is real, such as temperatures rising along with our production of greenhouse gases, and I also believe that it is largely human-caused. There is just too much proof of global warming because ever since we humans have industrialized, carbon dioxide levels have steadily rose, and as a result, Arctic ice is melting, sea levels are rising, we experience rising temperatures, and many animals have their habits destroyed. I believe that all of the proof we've been presented with, or at least the majority of it, is real, since there would be no motive for the scientific community to lie to society. And if there was false science, another scientist would find the truth, as it is a scientist's job to disprove things. Also, I don't believe that humans can generate this much electricity and become so advanced without some sort of obstacle, as there are consequences for everything. In addition, I believe that humans should try to convert to using cleaner, renewable energy, such as wind or solar power, as an alternative to burning fossil fuels. Even if what happens because of climate change during our lifetimes won't affect us greatly, it will still affect future generations, and it is my personal opinion that it is selfish to sit back and not do anything while knowing that future generations will have to work harder because of our mistakes. Thank you for watching my video about climate change, and I hope you enjoyed.